All right. Thanks a lot. Thanks so much for having me. So, yeah, I'm going to talk about social text data analysis. So, the general question is, what can statistical text analysis tell us about society? What sort of approaches might we be able to use to get something out of this? And so, there's a long line of work on content analysis done manually to assist in answering questions about, for example, the media. And that's been done for many decades. In some cases, you can find cases that have been centuries ago, where you're analyzing text and look at the concepts or ideas or opinions expressed in text, and try to do so in a systematic way with some validity to answer questions in social sciences, maybe social sciences, humanities, depending how you want to define things. But they do have a problem, but they're very labor intensive. So in general, reading documents is just hard and slow. And there's lots of corpora where we might have thousands or millions of documents, and we might want to make some sort of inferences about them or make comparisons between subsets of documents and things like that. And so I'm interested in looking at how to go to automated content analysis. It has some promises that might be able to help for a few things. Might be help for doing quantitative comparisons. For example, do people use certain words, certain concepts more with some class of authors rather than another? We might be able to use tools from pattern recognition to be able to induce or learn patterns or clusters, some sort of structure to the textual data that might tell us something about the concepts being talked about. And it might also help for qualitative drill downs. So in lots of these data analysis scenarios, you want to be able to look at individual examples and get more qualitative insight. And an important criterion for some sort of automated method is being able to support that sort of activity also. And so there's many emerging examples of this sort of automated text content analysis that are coming out now or have been coming out for the last few decades. And so far I've been able to find examples in things like political science, media studies, economics, psychology, sociology of science, a whole bunch of others. And I think what's needed is some unifying approach and some way of understanding what these things can and cannot do. And I don't know if I'm going to give this to you today, but it's kind of the question in the back of my mind as we're talking about these things. And in particular, lots of the research on how to process text or do some sort of rough natural language understanding comes out of computer science. And there's quite a lot of tools from areas such as natural language processing, information retrieval, data mining, machine learning. And one important challenge is figuring out how to appropriate these tools to be used in service of social science in terms of quantitative social science methodology, as opposed to purely engineering methodology or methodology to support certain types of user applications. So let's do like really simple examples. So the general question is, can text work as some sort of measurement of something? And a really rough and ready thing you might want to measure is what are people talking about in, say, from different political parties. And so this is one of these visualizations that the New York Times graphics group puts out like every week now. These are just counts of different terms and words being used in the convention speeches from this summer between Democrats and Republicans. And this is a primarily exploratory sort of technique. You can go through all words and take the counts of how many times do Democrats say it, how many times do Republicans say it. And putting some sort of ranking on these might give you some insight as to what concepts do the different parties want to talk about more. And this by itself isn't really answering a particular question, but it might be useful in some sort of initial analysis. And of course, in this particular one, there's argumentative flavor because the people who made it sub-selected the words they thought that were interesting and trying to give some explanations about why the Democrats are talking about automobiles, for example. I want to talk about the automobile bailout. Here's another example of text as measurement. So this is actually old work, actually, coming out of political science, international relations. And in this work, this is done by international relations scholars who are interested in understanding the dynamics of conflict and cooperation between countries, and in particular the time series dynamics. Like, do certain things tend to precede or come after conflict, or what tends to cause them, and things like that. And one thing of interest is looking at international relations as a series of events. And in particular, every time there's interactions between countries, that might constitute a data point. The only data source for things like this, in many cases, is things like newswire articles. And the manual content analysis approach would be to get lots and lots of undergraduates to go through each single article that mentions, say, Israel and Palestine, and say the type of interaction that's being talked about. Is it verbal cooperation? Is it verbal conflict? Is it armed conflict, et cetera? And so this work is based on an automated method, a natural language processing approach called event extraction, or sometimes called information extraction, where a computer program goes through the first sentences of lots of articles from Reuters or something like that, and looks for verbs, certain patterns of verbs, and certain patterns of different nouns that represent actors in international relations, and can extract these sorts of positive and negative interactions between them. And this is a graph of the output of such a system from article 1993. This has been done for quite a while now, of interactions between Israel and Palestine over 1982 to 1992. And it's using this sort of thing. This process is noisy. We don't have perfect natural language understanding. We have very poor natural language understanding. But it's able to have enough accuracy to get some of the long-term trends. So you can see things like invasion of Lebanon or the First Intifada in terms of 1 decade of Israel-Palestinian interactions. And this sort of information might be useful for testing theories in international relations and getting a better understanding of it. And it might also have predictive forecasting sorts of applications, which is part of the motivation for this sort of work also. And so this is an example, really, where the text is being used simply as a data source to measure something else. We don't really care about the text at all. We just want to have some measurement method of things that are happening in the world. It happens to be the case that a textual data set is where that information might be. So and first, practical advice for what methods to use, I think there's not really good answers for people who want to do social science sorts of research. There's a whole ton of different methods in the organization, and they're not really well organized, and everyone has their kind of favorite ones. I'm going to suggest there's 2 dimensions to think about these things. One dimension, there's how much computational and statistical complexity there is. This is a big issue because text is very high dimensional. There's a very large number of different possible words, and it tends to be very large. The data sets are much larger than things I can say fit into Excel or something like that. And the different levels, and depending on how much time or statistical complexity a certain method might take, it might affect what you want to use. And the second dimension is what's actually in the data, or what are the domain assumptions you have about the problem. And I just want to talk about the different types of things that you have in here. So in general, you can only interpret text through context. Maybe this is too obvious and trivial of a point. But you can have something like a whole bunch of documents with just words in them. These things mean something only based on the context of where it is in history, or where the relationships, or how they're being emitted by different political parties or something like that. And it tends to be the case that when you want to analyze documents in these social situations, there's always some sort of metadata associated with the documents, or maybe you could call it natural labels. So things like the time stamp on the document, like what year was it produced? What are the attributes of the author? Was it a male or female, Democrat, Republican? Sometimes the conversational context. Things like that tend to be important. And so these are things that might actually come to the data and be part of the object of inquiry. There's also things that might be less closely aligned with the documents, but might be associated with them and be of some sort of substantive interest. And so these might look like associated response variables for every document. So something like stock prices. Maybe you want a financial model that can predict the variance of stock returns based on the text of the report, a corporate report from the company, or a text about the condition that's describing conditions in the economy. Maybe there's voting decisions. For example, there's a text of congressional bills associated with our votes on them. And maybe people like certain things or not, or you understand the dynamics of political coalitions, et cetera. Citation networks. A document might cite a certain set of articles, or have certain articles that cite it. And maybe that's information which has something to do with the textual content you like to analyze. Another type of more knowledge-intensive side information is hand labels, so hand-labeled documents. And so there's lots of areas where you might want to go through documents and actually by hand categorize them. For example, you have a topical categories, some sort of taxonomy over them. So newspapers have or used to have departments of people who would do things like this. You see handmade topical categories in things like PubMed and many other places. Maybe there's genres of the documents you're interested in. Maybe there's types of events that are happening in them. Maybe there's the types of the things authors are expressing. For example, consumer reactions to a product or something like that. I want to say, feel free to stop me and ask questions at any point. It's totally fine. And so hand-labeled documents have a large amount of domain knowledge going in and you're doing more work, in the limit, you could just hand annotate every single document for the questions that you're interested in. The idea with automated methods is you can label only some of them and be able to infer labels or useful information about the rest.
Why do you call it assumptions then? If you know more farther along, does that mean you're making fewer assumptions or more assumptions?
Well, if you say assumptions that go into the statistical model or the computational model, so you're saying, here are the categories I think are important, then have the machine go apply them. Or, I think these are the important response variables for my logistic regression, something like that. And finally, there's also a huge class of techniques we might call hand-built dictionaries. So instead of labeling specific documents, you might make sets of words that describe something you're interested in. So topic keyword lists are kind of a classical way to do this. So get me documents that mention Israel or Palestine or Iraq, something like that. And that defines the topic I'm interested in, and it's done by hand by experts. This can be good or bad in different scenarios. Things like sentiment lexicons, I'll talk about an example of that. People very often make things like lists of names or list of verbs. Some of this event extraction stuff I was talking about is doing things like that. And this is you could argue, is a much higher level of knowledge. It tends to be hard for people to make lists of words and understand how they're going to be used in all contexts in order to do some sort of classification or analysis from them. But it's definitely another useful point in kind of the set of things that people use. So, yeah.
I'm sentiment lexicons. I'm remembering that on the Cornell movie reviews project, machine learning techniques beat out hand-provided sentiment lexicon by a mile, in fact.
Yeah, yeah.
Do you want to mention some things in there which definitely add information beyond what machine learning and clustering would do anyway in your right-handmost box?
Well, so for topics. So I want to get messages that are talking about, Barack Obama. That's less of a scenario where you would have a large natural corpus of text to train something like this on. I mean, so in particular, this movie review rating prediction problem, you have tons of these natural label documents, and they define the problem to be predict the labels of these documents. And the base of their finding was particular hand-built dictionaries we asked our undergraduates to do weren't very good at modeling this. But it might be the case that you're working on other situations where you don't have these natural labels for that. Like maybe, I want to analyze for Apple whether or not people like the new iPhone. And maybe that's not automatically in there. I need something that could be applied in different places. And some people argue that sentiment lexicons might be good for that. We have our doubts. I'm not going to defend it, but it's just a method.
Not necessarily need to do this arrow is monotonically increasing.
Well, it's
types of information you might have.
Yeah, it's not better. I'm just saying it's more work.
Okay.
More work from the human. So dictionaries, depending on how much you do, but dictionaries can be a lot of work from a human, especially if you want to do a really good job at it,
Yeah.
I think. And so the question is, how much work are you doing being a list of words versus how much work are you doing like labeling a bunch of documents by hand?
Okay. I can
Okay.
understand this arrow and work. Great.
Okay.
I get where it is.
Yeah, so, all right. So I don't want to bore you all with the abstraction. So I'm going to talk about 2 case studies that we've done about in the general area of detecting cultural phenomena in textual social media. And just to give an illustration of some of the different types of techniques you could use and kind of different points on these axes. And the first project I'm going to talk about concerns sentiment analysis or analyzing opinions over time, and another one on language and geography. And in the abstract I sent to Forrest, I promised a third one on internet censorship in China. I've actually cut it because I don't want to go over and I don't want to have too much stuff in it, but feel free to ask questions about it later if you're interested. But so the first one, it's a paper called From Tweets to Polls that we published. In computer science, you can publish at conferences. So in that sense, it was published in 2010 with my collaborators. So the problem is that we're looking at this project is to measure public opinion. And the question is, can we somehow do this better or do it in a different way or get useful information from social media? And the setup for opinion measurement is there's people in some populations, say the United States, and they might have certain opinions about, for example, whether they approve or disapprove of presidential job performance or maybe other things. And if you want to know what people are thinking, there's been developed already a very good method. You can just ask them. And in particular, people do things like polling and surveys, and been done for a very long time, has lots of great methodology around it. And it's not easy. There's a lot of things you have to know to get it to be done right, but this is a method that will do this. So you can ask people, aggregate the results, and put out something like, how's opinion changing over time, or maybe break it down by demographics or something that might be of interest. And so, of course, now people are using social media a lot, and people are writing their thoughts and opinions as text, and might be in some messy, complicated form. And they're writing these things into these data sources. The question is, can we do an automated query into this data source and get some sort of aggregate measure of sentiment from text that might reveal something about the original opinions that people have? So that's the question. And one of the big things we're concerned with is how to evaluate things like this. It's very easy to say I have a magical system that evaluates opinions. And so the way we're going to think about this problem is asking, can we get a similar measurement as traditional, well-understood opinion polling methodology? So the method we developed here is very simple in a few steps. First, we're going to start with the polling data. And so we basically looked at several polls we thought might be of interest to kind of model or emulate over time. One is polls and surveys of consumer confidence of the time period 2008-2009. So the index of consumer sentiment, which goes way back, all the way back to the 1950s. And also a similar one similar statistical properties that was put out by Gallup. That's supposedly a daily tracking poll, though I think it's more like once every few days, really. And we also looked at some political examples. One is for tracking polls into the 2008 presidential election, Obama versus McCain, and an aggregation of those. And another one is presidential job approval in basically the first half of 2009, which comes from Gallup. And so if you're thinking like this, being like, I have these polls, I'd like to get some sort of information from social media that's like them, the very first question is, how do you know which tweets correspond to which polls? You need some sort of topic classification. As this is where we do the simple thing that I mentioned before, is topic keywords. So we basically make by hand a list of keywords for the different topics. And so we're basically going through a subset of messages from, we're using Twitter, which is publicly available and convenient for certain reasons, may not convenient for others to use for things like this. We would just want messages that cover a span of time, and we subset to messages that contain a certain sets of words. And so for the consumer confidence poll, we chose words economy, jobs, and job as separate keywords. For the presidential elections, this is Obama, McCain. For presidential job approval, it's just Obama. And we're basically just doing analyses of the different keywords, analyzing subsets of messages that contain the particular keyword. So finally, the approach that we then take is for the messages that are topical, that contain this topic keyword, we perform a very simple type of sentiment analysis, trying to say, are you saying positive or negative things about Obama or about the economy? And so we use this lexicon. It's called the Subjectivity Clues Lexicon from a system called Opinion Finder, Wilson et al. It's freely available online, which is a useful property of it. I'm not going to claim it's the best or anything like that. But it's a list of words, of positive and negative words. And we use it just to create a very simple probability ratio. So we're saying the sentiment score for a particular day T around a particular topic word, say around the word Obama, is just the ratio, the probability of a positive word is in a message, given that it contains the topic word, divided by the probability of a negative word, given that it contains a topic word. So it's really just a ratio of counts. That's all it is. And so this doesn't actually, if you look at single messages, this doesn't always predict it doesn't necessarily predict the correct sentiment. In fact, it often makes the mistakes. But the hope is that the relative proportions of positive and negative turns might give some sort of overall signal. So one note on the sentiment list. So it's not very well suited for social media English. So you can imagine that in social media, people are using lots of things like emoticons, for example, or casual language. And lots of the words tend to be for a more formal register of English. And so there's some examples of words that actually don't make a lot of sense, make much sense at all in this lexicon. In particular, the word will. The word will is in this lexicon because it's supposed to be there as a noun. And the person who made this lexicon thinks the noun for the word will is a positive word, which, OK. But it's actually the most common match in there because the verb will is erroneously matched to it if you're just doing a simple matching technique, which we were doing here. On the other hand, some of these things make sense, like the words bad and the words good might indicate positive versus negative sentiment of the author. I have a few more examples here. In some ways, it might be okay to have things that are more formal register of English, because then you're basically subsetting. You're just subsetting different messages when you select different sets of words in this way. Now, another big issue when doing this is that the data changes a lot day to day. And in particular, there's a lot of volatility, especially in the samples we're looking at. And so in this graph, I'm showing this ratio sentiment score, which is the sentiment around the word jobs, and being showing it from day to day from January 2008 to May 2010. And the blue line is this Twitter sentiment score. So it's going up and down quite a bit. And yeah.
Around, you just mean within the same tweet?
Sorry?
You said around the word job, so do you mean just within the same
With the same tweet, yeah, absolutely. Question, yeah, when you deal with large documents, this becomes an issue, but tweets are so small, they kind of stand alone, which is nice to a certain extent.
Did they explain why they put Will on their list?
I was not able to find an explanation.
Because I'm wondering if people actually talk about the future more when they're optimistic.
They have it there.
People do tend to be overly optimistic about the future. Like 80% of Americans think they're going to earn in the top 10% after they graduate from high school, stuff like that.
Yeah.
So I wonder if they might actually put it on deliberately.
Yeah, these things are tricky. There's,
Common meaning.
yeah. So it's important to be cynical about sentiment analysis, I think. You can have these funny, complicated, abstract stories for these things a lot. I seem to remember that they also have part of speech tags in there, and they had will there as a noun.
Okay,
And it's just,
that would be a
yeah. I don't know.
Is there any mechanism in there to look for a negative word? So as like if a positive word from the dictionary is negated within the same tweet?
Yeah, so people often do things like look for the word not modifying it.
Right.
So we're not doing that at all. And so you could imagine if the word not was happening equal proportions and the probability of using the word not to negate something is the same across time, then it wouldn't affect the relative differences. That would be the hope.
Okay.
We care about the relative differences across time. Yeah. Or if negatives were used differently in April versus March, that would be a big problem for this sort of analysis, if you want to compare March versus April. The hope is you don't have to worry about that. So I don't know if we convince, I don't know, let's see. So this is just the simple time series, the blue line, so it's crazy. So what helps a lot is smoothing. So here we're now moving to 2-day moving averages. I left the equation out, but it's just averaging the score between today and yesterday, and then using that 2-day moving average. And so the blue lines are the new one, the green was the one before. And so what's happening is the volatility goes down a lot. There's just a lot of noise in the system, and it's basically shrinking down. And oddly enough, the correlation coefficient between the sentiment score and the Gallup poll also increases, because the Gallup poll is something that's much more stable. And I guess you can't see the Gallup poll yet, it's that black line. So what happens is you increase the smoothing window, is you get something that's more and more consistent. And so at a 15-day smoothing window, which is kind of a crazy thing, is saying we're going to average sentiment over a 2-week time period that we got off Twitter. You get this blue line is the Twitter sentiment score over time. And it has some rough similarity sometimes to this black line, which is the Gallup poll. So in particular, consumer confidence in 2008, 2009 is a very crazy time for the American economy, right? And there's a general trend of this sort of decrease through 2008, and then somewhere around spring 2009, it comes back. And yeah?
Does Twitter and Gallup let you do any demographics at all?
No. So we'll explore some ways to get at some of that later, but basically not a lot. Yes. Twitter, you can do things with profiles. And what we're going to do, actually, I'll show you later, is matching against census data for geolocation. And that's not the usual level, it's kind of aggregate. But yeah, there's not a lot in Twitter. It's a lot of these social media companies, it's basically you buy from them added information about demographics. Yeah?
Do you have an idea about why it's so noisy? About why you're
Not a ton. So one thing is that just in general, if you look at the time series for any word, there's just lots of day-to-day noise. Just lots of things that are very unstable. People are talking about lots of different things and change for different reasons. Another thing is that the data samples are quite small, especially early 2008. And so this is kind of a weird sample of Twitter also. Like 2008, Twitter wasn't really big yet, or was starting to become. So it's kind of odd. So part of the artifact of when we did this study, we had the data, happened to have the data then. Yeah.
Do you know? Oh, yeah,
That's the best question. Yeah, so we get some of these events. So I don't know if this blue line is really hitting. So this is September 15th, Lehman Brothers collapses. So on the black line of the Gallup poll, like people are worried about that at the right time when it happens. The blue line, yeah, maybe it didn't really get, I don't know, hard to say. This general trend of stock market recovery in March 2009, things getting better. Got this very large scale thing. So it's very rough. Might be getting something. One question is, which leads, the poll or the text?
Maybe the Twitter people knew Lehman was going to collapse, and then, they had the,
That's the advanced hypothesis. Yeah, I don't know. So I think an interesting question is, which leads, the poll or the text? You can do some sort of lead lag analysis. An argument for doing this sort of text-based polling is that you might be able to get reactions faster than it takes to do random digit dialing around and aggregate the results, and for the company to publish them in a nice way on their website to download. And so in this analysis, we looked at just cross-correlation between the sentiment score on day t and the poll day on t plus L. So take those two lines, you shift them, look at the correlation, shift them, look at the correlation, shift them, look at the correlation, the cross-correlation function, CCF in R, use R. And so this line is showing the correlation between the time series as a function of how much lag you put on the poll. And in one direction, it's indicating correlation when the poll comes before the text. The other direction is when the text comes before the text leads the poll. And so the thing is, the fact that correlation, if under a null hypothesis, the correlation would be bouncing around 0, right? So the fact it's up here at all is nice. And there seems to be some weak evidence that the cross-correlation is stronger on the right side, the text leading the poll. And the fact that it peaks at all in the middle indicates there's some sort of shared signal between them. But again, remember, these are long time windows. This is kind of large, broad-scale trends. So this is all for sentiment around the word jobs. So interestingly, different keywords do very different things. Is there a question? OK, so different keywords do very different things here. So I'll show the results for sentiment around the word jobs. And we have this 0.8 correlation. Sentiment around the word job, singular, without the S, is totally different. It's just noise. There's no shared signal. And if you look at examples, it's because when you use job by itself, it's used in other senses. It tends to be used more in certain semantic senses that don't have to do with the economy. For example, good job, or maybe you're talking about how your job went today. Whereas jobs with the plural tend, not always, of course, but you have more usages for things like economic jobs. But of course, you also get distractor signals. Like the word Steve Jobs is also a match on some of these things. And people like to talk about Steve Jobs on the internet. Like there was an iPhone release at one point during that time series, and it screws things up, things like that. And if,
and then people have more confidence in the economy. And,
it's complicated, right? And there's all these signals. And so you might want to, the argument here at least is to concentrate on ones that seem to be closer to what you would want. And sentiment around the word economy also doesn't really give anything. And so this is a lesson that I think sometimes people like to use word stemming, so taking things down to their linguistic roots, in which case almost all stemmers would turn jobs into job. If we had done that, we've gotten a much worse signal that doesn't follow the trends quite as well. So also looking very quickly at some of the political examples. So presidential elections, 2008 elections, looking at the sentiment around the words Obama, the word around McCain, they basically don't correlate to the polls at all. If you can keep looking at the sentiment around Obama, though, in 2009, so sentiment around the word Obama is just the same time series defined the same way. In 2009, Obama is president, and so there's no election polls, but there's a presidential approval poll. And it gets this kind of this very simple trend in 2009 that Obama was just becoming less and less popular during the whole year. And so it's getting this general thing. So here's the presidential approval rating of Obama going down. And in general, it's going down, but it has these weird spikes and things. So who knows? 0.7 correlation. I couldn't imagine using this as a replace for polling, right? It has some sort of shared signal, maybe. And so there's been other work in this area. So most recently, for the 2012 election, people were excited about doing things like this from Twitter politics. And so here's some analyses that are done by this company Topsy, or this is called the Twitter Political Index. I guess Twitter was involved with this work. And so they're doing these sorts of analyses where they're trying to get sentiment around the word Obama, around mentions of Barack Obama versus sentiment around McCain. And they have these analyses that are 30-day moving averages, and they're getting some correlations. Again, they're testing against Gallup moving averages in kind of the same way we did. And they have this whole same thing that it's still very volatile, even 2012. They're these long-run averages, and they get some of the same signals and some not. And they have these claims that there's good reasons why it doesn't match up, like that tweets might be more based on media focus and things like that. So there's been a lot of work in this area. I'll just say that we have some preliminary results that some analysis on Twitter data can give information similar to opinion polls, but I think it's not really well understood. One big question is who is using Twitter? So there's massive changes over time, especially when we want to do this time series analysis. Like 2008, 2012 are very different. There's questions about whether it's news or opinion. So if people are just repeating news headlines, maybe you're really just measuring the valence of the sentiment in media or mainstream media or popular media about what's going on in the presidential election or the economy. It might be different than what people's opinions are. Many people's opinions are driven by that. There's interesting questions of how different data sources might distinguish these better. For example, data sources where people that leave comments on blogs might give you something a little bit different. There's questions about how to do better text analysis. There's wide linguistic variation on Twitter, these ambiguity issues. And I just think it's a nice thing for future work, which would be good, is to analyze correlations to pre-existing instruments that are well understood. For example, surveys and polls that people have been doing for a while. And if you're interested in this area, there's kind of this nice cynical review paper called I Want to Predict Elections, and all I got was this lousy paper. It actually reviews a bunch of the work in the area. And because there's a lot of work in the area, there's lots of papers of mixed quality, so it's kind of an interesting overview of a bunch of them. You can check that out if you're interested. So I just want to say, so in the taxonomy of text analysis methods, this study was in the area of the simplest possible computational techniques. We did counts, we did correlations, we did ratios. And we did this based on word counting out of words, and we had some hand-built dictionaries, or we just made them up, or we downloaded them from another source, from some other people made. So next, I want to talk about kind of a different area. So I want to talk about language and geography, and in particular, how do words vary over time or vary over space on Twitter. And so this is work. I'm going to be talking about this piece of work, which we published in 2010, but also some follow-up work we're in the middle of that I'm really curious if anyone has feedback on. So I'm talking about the general area. So the general area this is in is sociolinguistics. In particular, there's lexical variation over geography or among different social communities. And this is a map that was famous on the internet, or used to be, about just the names people use for different soft drinks, and they're different in different parts of the country. So we're in pop territory in Chicago, right? Yeah. And so there's soda, there's Coke in different places. And there's tons of interesting variation in language. And it reflects things like geography, social status, race, gender. And we might be interested in analyzing this from data that's in social media. And so social media, there's lots of it and lots of casual use. And we might be interested in getting data sets from it. And a big approach that's used in the sociolinguistics literature when looking at this, called linguistic variation, is to search for known alternations. For example, different ways of saying you versus y'all. On the other hand, we look for some of these known variables. So yins is actually specific to the Pittsburgh dialect. So we're talking to some sociolinguists at University of Pittsburgh who worked on this. And it actually doesn't appear much at all on Twitter. It's actually from an older generation. Young people on Twitter don't use it. And so we have this question, are there new variables that we don't know about? So we look at this by looking at data, specifically from a subset of Twitter that comes from mobile phones that were geocoded with GPS or things like GPS. And it basically gives a latitude, longitude coordinate on the message. And so if you use Twitter on your mobile phone, it'll have a thing that pops up that says allowed use location. If you post that, then you go into these social media analysis data sets. So our corpus, this is for this work, we're going to have a small course from just 1 week, 2010. It's very informal and conversational. And many common words aren't in any standard English, Spanish, or French dictionaries. And lots of them, in fact, are conversational type with other people. If you look on Twitter in general, there's a very wide range of variation of the types of messages you see. So you have all these like official things from businesses, things that are advertising, websites, or celebrities. There's also this kind of other area of things that are more like status messages, but like what I'm doing today, or you're talking to other people, or having personal conversations. And when you subset to things on mobile phones and do some other clean, like we remove messages that contain URLs, we remove retweets and things like that, you really get a corpus that's very focused on casual conversations between people. And from the perspective of linguistics, this might be the most interesting subset. And in general, with these social media data sets, if you subset them in different ways, you can get radically different corpora with very different properties. So this is what we're using for this work. Now, in the first part of the project, we're going to use a generative model of text, a latent variable model, in which we're interested in discovering dialect regions in the United States and the words that characterize them. And the general approach we're going to use is probabilistic generative models. If you've ever seen things like hidden Markov models, naive Bayes, or topic models, it's basically that class of approaches. And so, OK, so the kind of the fun overview of these latent variable models is we use a thing called a topic model, which you hypothesize the text is the output of a particular stochastic process. Particular, here's the user, and the user might think about, you can tell like how dated the pop culture references are. You might think about some particular topics that you might be interested in talking about. And for each word, you pick the topic you want to talk about, and then you pick a word that's associated with that topic. And that generates the text. And then we have this model. We want to do something like maximum likelihood estimation or Bayesian posterior estimation, in which we're only seeing the output of the generative process. And through statistical inference, you go back and figure out what the topics were that generated that. And this particular one is related to something called latent Dirichlet allocation or topic models. And these tend to be more computationally expensive and heavier statistical assumptions compared to these word count examples down the bottom. And so our data organization, so here's how we set up this model. We organize the data into words and locations associated with users. In particular, we collapse all the tweets from one user into one large document, and we assign unauthor location. And if you haven't seen this thing called plate notation before, it's used in some of the probabilistic machine learning communities to represent replications. So there's a number of authors, like 3,000 of them. And with each author, there's many word tokens that they produce. We model locations with a Gaussian mixture model, which is a pretty standard approach for certain types of density estimation. And so locations are a Gaussian mixture, bivariate Gaussian over space. So I'm going to go through this fast because I think it might not be as interesting. And then authors' words are an admixture. This is what topic models are, over regional topics. And regional topics are come from base topics, and they're linked to particular regions. And so the idea here is that there are kind of base topics, like you might talk about sports, you might talk about food. Then in different regions in the United States, there might be specializations for it. So when you talk about food in California, you say the word sprouts a lot. When you talk about food in Chicago, you say something else a lot. And you might just kind of be a variation of that. That's a perturbation in the probability space. And so we use something called logistic normal distribution to do this. And we do Bayesian model fitting with variational methods. And so what we get out of it is this is the kind of the posterior estimates for which region do you belong to for different users. And the different regions are defined by these Gaussian distributions. And there's some blending. So you get some background regions that kind of cross a large part of the United States. And the membership is determined jointly by the text that people use and their location. And we did validation for this model by doing the task of location prediction. So pick a user, hide their location, have the model infer which region is more likely based on their text, and then do the Bayesian inference to figure out the distribution over where the location probably is. And our method gets a lower amount of error in the prediction, though I'm not sure if it's that great. 500 kilometers median, I believe. Oh, so it's k nearest neighbors. Sorry, these are other approaches. So the canon is k nearest neighbors. Oh, sorry. So ours is, this is the simple version of ours. This is the better version of ours.
And the K is in your version.
Oh, I'm sorry. K is 10 topics. So 10 base topics, and then a certain number of regions, which I think it model selected 15 or so. For this small data set, et cetera, et cetera. And so the thing about, so this model is designed to support exploratory analysis mostly. And so what happens is you get a base topic. And so topics are distributions over words. And so you can look at the most probable words, or the most probable words specifically for that topic, and just kind of inspect them manually. And so here's one topic that I find. So it's kind of a basketball topic. So it's talking about the names of lots of different basketball teams and basketball players. And if you look at several different regions, there's regional variants of it. And when people are talking about basketball in Boston, they're talking more about the Celtics. When they're talking about basketball in New York, they're talking about different teams. And they're talking about specific games that were happening this week in particular. What's kind of interesting is almost, though, kind of a simpler thing that just kind of the topics that people are talking about in this sort of conversational Twitter text. You get things like popular music, things like daily life, what are you doing today? You even get topics for things like emoticons, if you're preserving those in your text processing. And you also get these like special slang words like LOL, SMH, lots of words that we didn't know were words. SMH means shake my head, or shaking my head, I think. And so we also get regional variants of these, which some of them sometimes make sense, some of them don't. What this actually helped us do, though, is do a more careful drill down. And so these are word distributions of users who use some particular words from this data set. And we're just doing, this is a very simple plot, just 1 point per user. And so the gray circles are the word something, the kind of the standard American English form. And you're seeing that has a distribution that's similar to the overall distribution in the Twitter data set. The reds is for a variant, SUMTHIN, something. And this tends to be more focused in these regions of the United States. And this teal one, which might be hard to see, is sudden, SUTTIN. And that's incredibly specific to the New York area. And these are words you think would mean the same thing. They're what sociolinguists sometimes call linguistic variables or alternations. And there seems to be, geography seems to be an important aspect of where you expect to find them. There's also examples from things that are much more slangy or much more specific to social media or maybe SMS dialects of English. So the gray circle is LOL, which is very mainstream now. I guess that used to mean laughing out loud. I don't know what it means now. It's just its own word. It's really common. It's like in the top 5,000 most common words on Twitter, or at least in our data sets. LLS is the red one. It means the plural of LOL, or it means laughing like shit. I'm not sure. I've seen, there's hypothesized explanation of these things on the internet. And finally, here's the most local one, this example, CTFU. This is kind of an interesting distribution. So it's in mid-Atlantic and areas around Cleveland and Ohio. Yeah, crack the F up. And so it has a similar rhetorical function as the other words, right? And so there's tons of words like this. They find it in things like Twitter. All right, so here's another example. Here's 5 different intensifiers. So these are words vary and words kind of like vary. And so AF is one that's used in Los Angeles. It means as fuck. So use it in a postposition. I'm tired AF. For the New York area, there's one called dead ass, where you say I'm dead ass tired. And again, very specific distributions. The word hella. So hella is pretty interesting. So that's, I guess the colors are kind of blending together here. It's this purplish color. And so there's a lot of in the Bay Area, and it's also more spread out. So hella is kind of a classic like Bay Area, like San Francisco, Oakland, Bay Area sort of slang. It's been around for like a few decades now, I think. And there have been like linguistics papers written about hella, like where it comes from, how it spread, things like that. And this thing, it has some geographic locality in Northern California, but it's also spread to a certain amount to the rest of the country. And so one question is, well, if it seemed like it originally came from there and now it's spread, how does that tend to happen? Do people tend to do what teenagers in the Oakland suburbs are doing, or what's going on? And so this is the motivation for our work for a follow-up project on linguistic diffusion. And so we're asking the question here, which groups or geographic regions of the country influence others? We seem to have some cases where this might be happening. And where do linguists have to try and start? How do they start? And in particular, do geographic or demographic factors affect the probability of linguistic transmission of these novel types of slang or new words? And so this is work in progress. We have a preprint draft that we've posted on the internet. It's going to be presented at a workshop this year. I'm really curious for feedback. It has some things to do with influence and other things I think lots of people work on. And so the question is, how do linguistic innovations spread? In the sociolinguistic literature, there's kind of 2 groups of hypothesized explanations. One thing that's talked a lot is distance, maybe geographic distance or social distance. And there's certain conceptual models of linguistic innovations that they spread throughout a person's life. And it's going to be based on the likelihood of contact. For example, based on how far you live from someone else. That's how likely you're going to contact them. You might slowly get new words transmitted through there. Another related model is called the cascade model. So innovations might travel from the largest city down to the second largest city and so on. But it also seems important, a possible explanation is cultural factors. So different communities or different social groups might create certain words that might transmit between them differently. And so for example, there's many cases of African-American influences on standard American English dialect. So words like cool, rip-off, uptight, They used to be African American slang. So I think we now consider them to be mainstream casual American English. And so traditionally, sociolinguists often look at very carefully chosen linguistic variables, especially in phonology, which is thought to be a good indicator because you learn it when you're young. You can't change your phonetics later in life. And they're often concerned with variation across what they call apparent time. So interviewing a whole bunch of people who are of different ages. And so you learn something about the dialect that they learned when they were young, basically. And so with social media data, we can have a complementary approach. We can look at the time of, we can look at words with the times of when they're posted over a long period of time. And we can't look at phonetics, but we can look at lexical usage, like all these different types of slang. And so our approach here is to fit kind of a simple, somewhat simple regression-based sort of model to a large amount of real data. And there's also been some computational work that looks more at theoretical, formal modeling for these sorts of things. We're going to take more regression, simple statistical model approach. And so the data for here, and so part of this is, keep collecting Twitter data for a few more years, see what happens. So we're going to look at 86 weeks of data in this part of the talk, with a much larger amount of data now, 44 million total geotag messages, over 500,000 authors, and doing weekly level aggregation. So our time steps are going to be every week. And we're not going to do automatic induction of these linguistic regions for this. Instead, we're going to do something simpler, simply assign them to the closest major city. So we're going to use the metropolitan statistical areas that are defined by the US government. And in particular, we have demographic information about them from the US Census. And this is going to be nice because it has simple interpretability. And we're also going to focus on kind of a subset of most frequent words. And in particular, we look at the top 10,000 and we filter down to words that are used at least 5 times in 1 week within one metropolitan statistical area, which is going to give us 1,800 words for these analyses. These types of filtering steps can make a big difference on the sorts of results you get. So here's just a few examples of diffusion that happens in this data set. And so here's kind of 3 different snapshots for several different words. And so in this row, here's our good friend AF. Really, in the start of the data set, late 2009, we have an 8-week period where the only place they use it more than 1% of authors use it at least once per week is Los Angeles. In the middle, in kind of a middle time window, like 30 weeks later, we're seeing that it's spread. It's being used more often in several other places in California, but there's also kind of a cluster of usage around Georgia, around Atlanta, and other places near there. And then finally, at the end of the time series, it's much more widespread in the United States.
How is your sample size varying across this time series?
Good question. So it does vary. And so we're looking at the probability of usage instead of looking at simple counts like that. So we're looking at the probability that an author uses it in time series. I can't remember the numbers, but it's a lot.
You're thresholding at having been used 5 times in that week, so even looking at the probabilities, if you have a big sample, you're much more likely to pick it up at all.
Yeah. That's a big concern.
So yeah, I mean, I have a project that's ran up against the same problem.
Yeah. So we have a fixed effect for time. I'll show on the next slide for the modeling. There's limits of what you can do with the raw data analysis, exactly. So this is raw data analysis, but we'll get to more in a second. So there's a few more examples for another one. So bruh is kind of like the word bro. This is the novel emoticon. We think it's a synonym for a frowny face, but when you're just inspecting these things manually, it's a little hard to tell. And these transmit differently. And so the new emoticon that's starting place in East Coast, Florida areas. So it turns out, so we wanted to model this as diffusion network where the nodes are cities. So we're doing the city level aggregation. In particular, we have these basically 200 nodes and we want to see which ones tend to transmit to others. And we have this kind of lead lag definition. You may have controversy over causal interpretations, whether this counts as influence of transmission. But the idea is that if a word is popular in region R and it later becomes popular in region S, that counts as a sort of influence of transmission link. Or maybe we can call it just diffusion, something like that. And so it turns out you can't use simple cross correlations. There's confounds for the sample size problem. There's also issues of the size of the region. So if you're looking at a small city versus a large city, the large city has more variation just because it's larger. And there's also issues of global events. So things like TV shows and holidays cause big spikes. And like small differences in the timing of the spikes looks like influence, though really we know it's more of a common cause story. And so we're going to put this inside a model where the influence is a linear dynamical system, but it's embedded in something that has fixed effects to control for these things. And so this is a logistic binomial model. So for every word, we're saying there's binomial probability of the count of how many authors use that word in a particular region in time. And so that's the C and the S. That's the data that's being modeled. And this is a function. The mean parameter is a logistic sigmoid, just a logistic regression sort of setup, where we're going to have effect for the overall frequency of the word I, like across the data set, have an effect for the general activation of a particular region at a particular time. So this is what controls for things like small cities. People tend to not tweet very much. They don't tweet many words at all, versus large cities might have much broader coverage of all words. This coefficient controls for some of that, and also that these samplings can change over time also. And we also have a parameter for the global activation of a word at a particular time. And this is to get things like the names of characters in TV shows that people talk a lot about one day across the United States, then they stop. And these things all happen a lot, and it was really annoying. But finally, the very last term is the thing we actually care about. It's a parameter that explains the leftover amount of the probability mass for that particular word at that region and at that time step. It's the logistic regression coefficient for that. And in particular, it has a prior distribution. The prior distribution is a latent vector autoregression over time, similar to Kalman filter linear dynamical systems, if you've seen that, in which the mean parameter of this eta variable is just a linear combination of this influence matrix coefficient of linear combination of its usage in all other regions. So for Los Angeles, there's 199 coefficients across all other regions, and saying if things are popular in New York, maybe they're popular here also. And that's what the A matrix gets. So we do model fitting with EM. There's 30 million variables, so it takes a while. Really, you have to do lots of tricks for things like this. We're fitting eta with various methods. You can see the paper for details. And so these Kalman filter, Kalman smoother sorts of things basically impose smoothing on the time series structure. Some examples of that. And we wanted to really analyze the transmission edges, or these influence edges in this A matrix. And so we've simulated a number of posterior samples. And the question is, which of these these non-diagonals, these edges, are statistically significantly non-zero? And so this is a multiple hypothesis testing problem. And in multiple hypothesis testing, the simplest approach that people usually use is Bonferroni correction. In this case, it's too conservative. When you have a very large number of tests, Bonferroni correction says you have to divide by the number of tests. And it's because it's controlling something called family-wise error rate, where it's a probability of seeing at least one false positive. In these cases, it's argued that you might want to care about something else, something called the false discovery rate, which you want to bound the expected percentage of false positives in the set of coefficients that you're selecting. And so we use this. It's called the Benjamini-Hochberg correction. It's really common in computational biology now, and I think for lots of large social science data problems, people should be using it. And it's really simple. It just comes out to a ratio between the tail, the amount of under null hypothesis, versus how many you see that pass empirically. And so we're basically, here's all of these are representing the elements in the A matrix, and we're thresholding things that go beyond a certain z-score threshold based on the posterior distribution. And this yields 3,500 edges that we estimate have statistically significant non-zero effects. And so here's the transmission network. And so these are edges that are, nearly all of them are bidirectional edges on this A matrix between different cities. And we're looking at the top 50 ones, and we're only looking at the strong effect examples. And so in particular, one interesting thing is that lots of the effects tend to be geographically local, in which we have this transmission effects tend to happen in between places that are close to each other. And there are some cases of long distance transmission, but they tend to be less common. And we can also look at specific examples. So these are the ego networks on this transmission network. And so the blue edges are bidirectional. Greens are going outward. Yellows are going in. And so you can see some examples. So New York and Los Angeles have this long distance connection. New York also has lots of outgoing connections of places that New York influences but don't influence New York. And you can see a few examples. These are just the top 4. And these places have just very different connective structures. You can see lots more examples. A few interesting comparisons are distance seems to matter, but there's a question of how does distance matter. These are the 4 largest cities in Texas. They're all within this top 200 city list. So Dallas, Houston, Austin, San Antonio. There might be some similarities between Dallas and Houston, but Austin and San Antonio have very different connective structures to different cities in the United States. And so when I show this to my friends from Texas, they have lots of folk hypotheses about why you might see things like this, right? Like Houston. Yeah, exactly. Yeah, so you can make lots of jokes about, cool TV shows from Seattle and Portland.
What does each arrow mean again?
Sorry?
So what do the arrows mean again?
So the arrows mean a statistically significant non-zero transmission effect between the two cities. So if a city uses the word a lot at time step t, the other city has a higher probability of using it on t+1. And the blue means bidirectional, so they're influencing each other. If you believe the model is capturing something called influence, maybe just capturing co-occurrence, lagged co-occurrence.
And so like allegedly a big impact of like Chicago and Houston, for example.
Mm-hmm.
Right, that's like one of the things we're seeing.
Yeah. That would be an example. And that one is bidirectional.
So again, like that doesn't seem to make too much sense to me. I don't know, but so do we have a way of validating any of these?
That's a good question. We are working on it. So what I want to do is you can do these transmission networks for single words or kind of smaller things that you can look at and see what they are. Statistically, it gets harder and harder because then you're pushing yourself to have less data. So these are transmission networks done on the full, like all 1,800 words with all their time series. So in some ways, that's a weakness of the approach, that we're kind of aggregating together all these things. I'll show.
Like big cities are more likely to be sources?
Yes. Yeah. So.
Sociolinguists, I think,
Mhm.
would believe you on that,
Mhm.
because there are very detailed studies indicating that language change is higher
Yeah.
in dense urban concentrations.
Yeah. So in particular, we looked at that with the following analyses. Great question. Okay, not this slide yet. So this slide is the looking at symmetric properties of transmission. So looking at the probability that an edge exists at all. I'll just look at the, this is a logistic regression version. So we're looking at whether or not one of these links exists based on the test we were doing. And so we get statistically significant effects for a number of things. Product of populations we put in there. In particular, some sociolinguists have used this as a way of measuring large to large transmissions or the size of city effects. And that has a positive impact on the probability of having an edge. Distance is inversely correlated, so places that are close together tend to transmit more. And there's also effects for the absolute difference in various demographic variables, percentage of white population, African American, Hispanic populations. Also a variable on percent urbanization for this metro statistical area. And there's some variation on that. So this is a rough urban versus rural measure. And we also have another form we did on predictive validation. So this is actually predicting influence links. And you can look at what are the held out accuracy under cross validation, and you can look at what the accuracy of that is when you take out certain feature sets. It's kind of a different way of viewing what logistic regression coefficients would be giving you.
So like the percent demographic, percent Hispanic, whatever, that's of both cities?
So that's the difference between them.
Oh, okay, sorry.
So this is for a percentage difference, it has that effect. Sorry, I don't have the.
Difference in percentage.
Good question. I don't remember it right now. Oh, the direction is a larger difference, means a smaller probability of a link. So places that are linked tend to have similar demographic profiles. So it's sort of homophily.
And the link is not directional? You're not looking at who's influencing who?
Right. So this analysis is symmetric. So it's in either way. Though most of the edges actually are symmetric.
Okay.
So these analyses are the asymmetric version of this. So we're looking at difference in demographic attributes between senders and receivers. Going to the regression version, these are regression coefficients for predicting the direction of influence. And the statistically significant ones here are population size. So larger cities tend to transmit more in general, and ones with high percentage African American populations in this sample. And so Twitter is known to skew towards minorities. though we don't have exact demographic compositions of this particular data set. But we are using the variation between different cities, so the African American populations have some inferences about this. So tentative conclusions is still work in progress. There seems to be strong rules for both geography and demographics. We're a little surprised to be seeing these demographic effects, given that we're doing metropolitan area level aggregation. So it's not just Atlanta; it's Atlanta and all the suburbs of Atlanta. It's not just Chicago, it's actually like Chicago, Joliet, Naperville, I think. These places are pretty far away, right? So these are large. These are aggregations of counties. And so really, to really get demographic effects, you want to go down to something more like neighborhood levels. So we're hoping to look at that in future analysis. There's some evidence that racial homophily is very important, or I should say similar profiles of racial demographics. And it will be really interesting to get more at socioeconomic class. This might be a little bit trickier to assess from census data, especially census data combined with Twitter in this way. For Twitter, we only get the geographic position. We might be able to get something out of that, though. And there's also could be issues with the word independence assumption. So we're modeling these almost as completely different time series of words, but some words have all sorts of connections. For example, there might be different variants of the same word, bra and bro in this case, or there might be topical sets of words, which we're looking more at our previous project. Right now we've been using a word independence assumption. And so this might be an interesting thing to look at also, not sure. So very briefly, so we have this range of techniques. And so here we have more of this non-convex MCMC sort of optimization for things like the time series model. And we opted for more simple regression classification sorts of approaches, which I think are more, in some ways, are more useful for the social science sorts of questions compared to some of the black box machine learning models. And number of errors for future work. So all of this work was done with single words. If you care about things like natural language understanding, there's lots more things you could be looking at. We were looking at names and opinions a little bit, but maybe there's discourse relations or deeper semantic relations, which I didn't have time to get into, but it could be very interesting, I think, many areas for future work. So I just want to say all the papers and slides are available on my website. We'd love to hear any feedback you have, and thanks.
I appreciate the space where you're replacing the text analysis methods on these two different dimensions. You've obviously come up with a number of other dimensions. It seems rather easy to replace those things. But it'd be lovely to have some exemplar studies sort of placed on here. I think that would actually be very illuminating. Often when you start these discussions, and depending on the objectives, be able to know where you're going to be working within that space could help shape or correct particular things. Can you just go back to the last slide?
Yeah.
So the bottom dimension, this is both domain specificity and the complexity of the representation. That's the unit of analysis?
I was thinking of more of just the amount of domain assumptions or the richness of the data that you're putting in. You could think about complexity as related to that. So maybe you have a dictionary that's not just a list of words, but it has, the syntactic roles words have to play in order to qualify as an example of the concept. You could imagine doing things like that. Or maybe you don't just have hand-labeled documents, but you have a really intricate hierarchical taxonomy over documents. I was thinking of it more of just how much knowledge do you put in. And so in lots of these artificial intelligence areas, at least, you talk about the domain knowledge for the problem that's from the human experts, and then the amount the computer has to make up. So that was kind of the dynamic I was thinking about. Maybe it's an overly AI instead of social science way of thinking about it, but that's what it was.
Yeah. What tool sets were you using to do all this analysis?
Various ones. So things like, Python for scripting, or MATLAB or R for numerical computation, or standard stuff, I think.
Yeah, so right now it looks like you took all your data and you fit this model, and then we try to understand what happened, right? It seems like you're in a good position to take some more steps. So, for example, Vespignani published a prediction of the outcome of American Idol election in advance, and then he turned out to be right. So you could try to predict stuff into the future and see if you're right. Or, of course, this is already computationally very expensive, but I wonder if you could do cross-validation, where you left out part of your data and looked at the extent to which the model parameters you got a subset predict those you would get on your left out set. Which would be kind of standard drill and natural language processing, showing your way onto something.
Yeah. So the location prediction was the way we validated the topic clustering model. But we haven't done anything like that.
Yes, I'm very interested in this, in the sort of dynamics and direction of influence stuff. And I wonder if you could cross-validate on that.
Yeah. So it's tricky when you have time. I think the way to do it is to do kind of a forecasting validation. So you're like only look at the data up to time step t, and then out of sample is the feature after t, or t plus 10 or something like that. And so hypothetically, the model should be able to do that sort of thing. But it would be a good.
It would be nice to see that. Really would be. Of course, you'd burn up some more computer time.
Well, that's the job.
Did you find? Was your model able to estimate negative links such that if there was some slang in city and time t, it was less likely that it would appear in time?
So this model actually allows for negative links. We did get some. They were much fewer and tend to be smaller magnitude than the positive links. And we didn't look at them that much. Maybe we should have. Yeah, I mean, there are these things like, they're like the cities that like have no very connections to other places.
You don't really believe it is, or you?
We were thinking that we wanted to force the model to only have positive links because I think the interpretability is cleaner for those. We computationally, statistically, we didn't know how to do it, so we didn't do it. So, I don't know.
I mean, it seems like, many kind of social logical theories think that that the reason why people do stuff is to get away from other people, right? So
So there's uncool places.
Yeah, cool places. You're like, oh, people are starting to use this language, and now we have to stop using it. So it seems like I would really be very interested to see if any of those negative links were kind of actually not just noise.
In your first study, where you look at opinion polls and Twitter sentiments, just curious if you or other people draw a third line or sentiment analysis on news reports, blogs, these more official sources, how that fits in the picture.
Yeah. So people use it for particular things in different ways. That's definitely been done. And so the example of there's a nice example in like finance where they were studying opinion articles in the Wall Street Journal. So like a specific focus corpus, you have a good idea of what it's doing. And looking at that, the relationship of sentiment or sentiment-like thing estimated from that against certain statistics of the stock market. I think volatility, I can't remember though. But yeah, I'm not aware of work with sentiment analysis for this opinion polling reproduction problem. In some ways, that would might be more interesting than Twitter analysis because you'd be analyzing the effect of the media, the time series relationship between the media and public opinion, and maybe analyze just like mainstream media. That might be a significantly different thing than what Gallup is measuring. And so you could see what types of media drive public opinion, or may they follow it? I don't know.
Or media sentiment analysis to your Twitter sentiment analysis, how those stack and coordinates.
Yeah, so some people have a hypothesis that media landscape is changing so that there's more ground up sorts of things that become big in the blogosphere, and they push the mainstream media in doing things. There's lots of anecdotal arguments for this. This might be a way to disentangle some of that statistically.
In all of this Twitter data usage, how do you handle retweets?
Oh,
Yeah.
So I forgot to mention that. So for all the geography work, we throw out all retweets. So we're treating Twitter in a very strange way. We're trying to get rid of the things that are kind of distinctive to Twitter. We just really want lots of casual words from casual conversation. But some people point out to us that retweets might be a way that novel words transmit. So maybe that's something we could look at. So yeah. And so we're just trying to take the hypothesis that some work in influence analysis assumes that you have the entire network. It's just you're just given the entire network how nodes could possibly interact, and they want to analyze, the probability that you get infected when from repeated exposures. And so our approach is saying, we're not sure how these linguistic transmissions happen. Maybe they happen through face-to-face conversations. We have no idea. So we're just going to use this as kind of a partial data source for that. So maybe it's better to do something in the middle. We're using all the information we can, but that's what we're doing for now, at least. Yeah.
A lot of the work you've done here is dependent upon the location of where the tweet originated from. Do you have any idea what percentage of tweets you have reliable information from?
Yeah. So the number, it's always in our papers. I think it's around 3% or so of tweets have this information from this data set, which Twitter tells us is a uniform sample of all public tweets. So there's usually 1 to 5%, depending. That's kind of the range you get for this, I think.